Okay, we're recording.
Yeah.
So again, good afternoon to one and all here. We didn't have a discussion last week. It was a very hectic week, but we'll definitely have one this time. And okay, we've got someone else. So today's topic will be very interesting because unlike the previous topics, we can talk a little bit about the technical stuff here. And a lot of you know about those technical stuffs because we had it in our project section. We discussed it, especially Rohit. We discussed a lot of it. So you'll be able to associate with some of these concepts, having learned about it earlier. So let's start then, shall we? Right. So jobs. There are a variety of jobs. We do all kinds of jobs. We've heard of farmers, we've heard of servicemen, manufacturing people. What do you say? Janitors. What do you stock market brokers, investors? All types of jobs. And the nature of jobs also vary depending on where you are, what is your level of education, a lot of other factors which we cannot really state down right now because it'll take forever to state them down. Now, why do we work? Why do we want jobs? Well, like a very select number of us would be able to say in the future, or a select number of us who are working right now could be able to say that we are working because we love our job, because we are passionate about our job. And the general public or the others who work primarily for money. And why do they want money? Because money enables you to put food on the table. It enables you to live in houses, and it can enable you to do a number of different things: go out partying, buy stuff, basically anything and everything the mind can imagine. Work enables us to earn the tool which can then enable us to further our lives in the way we want it to. So what is the issue at hand? I mean, we spoke about jobs. These are all fairly standard things, right? So what is the issue at hand that forces us or that makes us discuss this with respect to artificial intelligence and machine learning? It's this picture that you see right in front of you. Our workforce or the job force is changing in ways that we could never imagine in the past because of the main aspect of automation. Now, what is automation, you may ask? A lot of you may know, but for those who don't, I mean, you'd be a very small number, but I'll still go over it. So what automation does is it replaces humans with robots or with machines that can do a particular task at a fraction of the cost and with absolutely no, fuss or emotional troubles whatsoever. Because robots, they are not emotionally, connected or emotionally reactive, if that's one way we can put it across. So it's not a very new concept, the concept of automation, because it's been happening for quite some time. We've seen robots or we've seen machines take over the manufacturing industry. We are producing at a scale that was unfathomable, let's say about 100 years ago. And what automation does is it improves our scale of production from a very small amount to a global scale. That's why nowadays we're able to, manufacture and export on a global scale, thereby improving improved economies means improved personal lives. Improved personal life means happiness. And at the end of the day, we work because we want to improve our happiness, or we want to lead happy lives for the most part. And right now, this is a quote which was mentioned by Andrew Yang. He is an entrepreneur, and he was a former Democratic presidential election nominee. So he was there in the early part of the presidential race, but then he dropped out. And one of the main features about his campaign was the policy of universal basic income. Now, for those of you who don't know, universal basic income is the policy which enables every US citizen over the age of 18 stipend of $2,000 per month, irrespective of your conditions or any other aspect. All you have to do is be 18 years of age and a US citizen. Now, one of the main reasons why he brought this policy out was because of this quote that he said. which was in the next 12 years, 1 out of 3 American workers are at the risk of losing their jobs to new technologies. So he said that a number of US jobs will be taken away by automation within the next 12 years. And we've got stats which actually support that assessment, because as you will see here in this stat over here, the employment has been reducing ever since 1990. Now, in the earlier stages, it was reducing at a relatively easy pace because technology was improving very slowly and steadily. So the decline was also gradual. But over the turn of the new millennium, you could see a sharp decrease in the employment, and this is with respect to the field of manufacturing, because then we had the internet burst, we had the introduction of Wi-Fi into our systems, which completely changed the landscape of workforce and how we connected with people and how we improved our manufacturing scales, techniques, and production tools. So that is one of the main features that automation and other technologies that complement automation has brought about to the field of manufacturing or the general job market in particular. So I just skipped a slide. What we will be doing today is we'll be discussing about the impacts of AI in the manufacturing field. And this is another quotation. This is actually an analysis which was conducted by Oxford Economics, which stated that up to 20 million manufacturing jobs around the world could be replaced by robots by 2030. 20 million manufacturing jobs. Now, you might say, well, yes, definitely, with the passage of time, the nature of our jobs will change naturally, because that's what history has shown us. We had the Industrial Revolution, which completely changed the landscape. Now we have, a robotic revolution or an AI revolution that is changing the dynamics. We are just in another wave. We just need to gear ourselves for that. Now, if this is so much as an inevitable thing, then why is there this perception of fear amongst us? Or particularly over here? Because according to the National Association of Manufacturers, manufacturers in the United States account for 11.39% of the total output in the economy. And it employs around 8.5% of the workforce. Now, what does automation and AI power technologies do? We are talking about risking a sizable amount of people engaged in the manufacturing industry to redundancies, because we've got automation and AI in power technologies that are replacing their jobs. Now, it'll definitely improve their output, because traditionally speaking, technologies have always improved the output because we've improved our efficiency, we've improved our tools. The issue is who's going to work, and if they don't work, then how are they going to lead their lives? Therefore, it is important to have a conversation about this. Now, you might all this while I spoke about robots and machines that do a specific task, and you may have a legitimate question, but aren't robots specifically meant to do a particular kind of task? I mean, they're not going to do anything on their own. They're not going to think about the efficiency and do it in an entirely different way, like how humans do. Because we always like to find new ways of improving our productivity or improving our profits and things like that. But a machine won't think like that, because you just program it in a particular way and it does that. So where does artificial intelligence come from? Where does machine learning come into the picture? It does, because with the introduction of machine learning, we have discovered a very interesting and valuable opportunity of completely reshaping our manufacturing tools, methods, and techniques. And it does play a role in the following ways. Now, there are a number of ways in which artificial intelligence improves the industrial opportunities or industrial scale of production and efficiency. But we'll be talking about two aspects about the industrial process or the manufacturing process that AI has scope of completely revamping: predictive maintenance and predictive quality and yield. Now let's start with the first one. What is predictive maintenance? Okay, can anyone tell me what maintenance is? I mean, I've been speaking for a long time, so I'll hand it over. Does anyone know what maintenance is? I mean, what is maintenance in the manufacturing industry? Or
I I think maintenance in terms of manufacturing would have to be like making sure something is up to date, making sure like, fixing something when something's wrong. Like basically updating the thing that needs to be like fixed. You're updating your product, you will, like car maintenance, updating the engines or robot maintenance. They update the robots so that like keeps working for another few years. So that's kind of
Exactly.
what it is.
Perfect. So, I mean, the name is quite self-intuitive. Maintenance means ensuring that whatever tools you're using are, kept in a particular way so that they keep functioning over a period of time. And to do that, you have to conduct regular checks and you must make regular assessments so as to ensure that your machinery doesn't break down at the worst possible time and force losses onto you. Now, what is predictive maintenance? Now, on over here, you can see three different graphs, each representing a different type of maintenance style. The first one is reactive maintenance. Now, as the name suggests, reactive maintenance is the maintenance that you do when you're faced with a problem. And if, as a graph shows, this means failure. So, how do you then address, let's say, you have an engine that you got a piece of machinery that just broke down. So, how are you going to address that? So the process that you do after a particular problem has occurred is called reactive maintenance. If a machine fails, whatever process you take over after that is your reactive maintenance. Now, what is the issue with reactive maintenance? I mean, there are obvious issues, right? Can anyone tell me what the obvious issues are with reactive maintenance?
Usually the damage is done by the time the active maintenance comes in.
Absolutely. I mean, you said it pretty succinctly. Reactive maintenance means you're basically, what do you say? You've incurred all the damages, you've affected or damaged, you won't be able to produce because now that becomes a redundant piece of machinery which you'll have to put aside until you can repair it. So you're incurring a lot of cost in terms of money, and there's also time cost because now you're talking about not having that piece of machinery for quite some time because machinery takes time to repair, right? So it's a very heavy, it's a very cost intensive maintenance style that people adopt. Then we move on to something called preventive maintenance. What does preventive maintenance mean? You can have a look at the graph and tell me. Uh, would anyone else want to answer?
It's basically like when it's like kind of like over time, you feel like you need to be safe, so you go to the workshop and just have whatever it is fixed so that it like still lasts the same amount of time as long as it's in usable condition.
Absolutely. So I don't know why they named it reactive and preventive, but if I were to put it in a more, in an easier manner, I would say the first one is curative and the second one is preventive. And why I say that is because prevention is better than cure. The second one approaches maintenance in a safer manner because it wants to prevent issues before they can wreak any more havoc. And the first one waits for the issue to occur in order to ensure that you address that issue. So, as the quote suggests, prevention is better than cure. Preventive maintenance ensures that people work on a machine or maintain a machine over a period of time and in regular intervals so as to ensure that that piece of machinery does not get damaged. Oh, am I getting cut? Can you hear me, all of you?
Yeah.
It's mostly fine. It just glitches out time to time.
Oh, okay, fine. If not, then just put it in the chat. I'll address it. So again, preventive maintenance is basically doing it over a period of time so as to ensure that it doesn't reach that terrible condition of then having to, replace or then having to put aside because you didn't address it at the right time. And so you're trying to reduce your losses by implementing a preventive maintenance style. Now, what are the obvious issues? Preventive maintenance. What do you think are the issues with preventive maintenance?
Let's let some of the members say something. Do you guys want to answer?
Yeah. Anyone else? Amir, Israel, do we have? Yeah. Henry, would anyone want to answer? Yeah, put it in the chat also. It's fine.
Yeah, I was gonna say that that preventive might sort of be more expensive than the others. I don't know.
I mean, that's
Yeah.
definitely one way of putting it because it's expensive because you'll have to keep doing it over a period of time. Look at the graph. It shows that spanner near that areas where it's dipping. So you have more frequent maintenance works or maintenance repairs because you're doing it over a specific period, specific intervals of time, so as to ensure that it doesn't get damaged. So more maintenance works means more costs. So obviously you have got a cost element that factors, and you also have a time element because now you have to maintain it in every after every specified interval of time, meaning you'll have to employ those people for more number of times, which means greater cost and greater time also. Because when you're maintaining it or when you're doing maintenance works on it, those machinery cannot then be used at its maximum capacity. So yes, there's an element of cost and time. Now, this is where predictive maintenance comes into foray, and in a way to say, yes, the other two do not work, but here I'm the best way of enabling maximum efficiency and best output. Now, why is predictive maintenance the thing, and how is machine learning, enabling companies to use predictive maintenance? So predictive maintenance follows a particular algorithm, and as predictive suggests, it predicts when a particular piece of machinery will fail or get damaged. Now, how does it do it? It follows a basic algorithm of acquiring data, pre-processing data, identifying condition indicators, training model, and then deploying and integrating. Now, this is something that Rohit spoke of, I guess, 2 lectures ago. Right, Rohit? Am I right?
Yeah, it was like one of the things in I think week 2.
Yeah. So, I mean, he didn't exactly explain it like this, but it kind of involved these elements. So first you acquire data of the various aspects that go into maintenance, like what is its runtime, how much heat is produced from this machine, or what other factors are involved in ensuring that this machine hits maximum efficiency. So you collect all those data. And then what you do is you then pre-process the data. What does pre-processing mean? Well, pre-processing can mean anything from wait, yeah. So pre-processing can mean anything from removing unwanted data, or removing data that you think do not have any kind of value, or even assigning weights, like what Rohit said a couple of, like, I think 2 lectures ago, when you assign weights to various aspects so as to indicate how important it is in your eventual analysis. So that's how you pre-process it. And then you go into identifying condition indicators. Now, what are condition indicators? Condition indicators are conditions which tell you that yes, this is a factor that if this condition is satisfied, means you can go ahead. If this condition is not satisfied, then you cannot go ahead. Or in the context of manufacturing, condition indicators could mean if temperature, then it is in its best threshold, then you'll have to conduct maintenance work. So those are condition indicators which go into this predictive maintenance algorithm. Then what do? You train the model, because one run alone does not make it the best algorithm. So you have to keep training it so as to ensure that you have the best possible factors that you're playing with, so that when you're faced with the prospect of predicting, you predict it in such a way that you incur minimum cost and maximum efficiency. So keep training it by using a number of different test data, or by just running it over a period of time. And then finally you deploy and integrate. So this is basically the predictive maintenance algorithm, and I hope most of you understood this.
Sagar, could I step in with an
Now,
example that
what are the
might?
advantages? Um, One is cost effective uh, for obvious reasons, because now you're predicting the best possible time to. Oh, okay.
Sagar, could I step in with an example on the previous slide that might help out a bit?
The best possible time to conduct. Can you,
He's glitching again.
yeah,
Mayday.
carry on.
Sagar, hello?
Say something.
What? Wait, Sagar, you're muted.
Right. So we had a major issue over here, but hopefully it's tackled. Yeah. Rohit, you wanted to say something?
Yes. Do you think you could go back to that previous slide about the process of predictive maintenance?
Yeah. Here you go.
Yeah. So one example that I've come across, this is not exactly manufacturing, but essentially banks try to assess fraud before it happens, like assess the risk of fraud before it happens. Um, and basically there's like it keeps collecting details of customer data and their behavior with the bank, how much they're withdrawing, how much they're depositing, and over time it starts to plot a few key things that happened right before someone commits a fraud. I don't know exactly what they are because I don't work in a bank, but the model identifies a few key things that indicate that this person is about to commit a fraud. Sometimes the model does it, sometimes humans do the data analysis like themselves and identify this factor usually corresponds to a fraud about to happen. So that's like identifying those indicators in the middle on the slide, and then yeah, the rest is yep.
Right. So there you had another example of how you could use this across another industry altogether. But this was one of the things that the basic that I wanted you all to have an idea of. And like I said, advantages are it's cost effective. You can manage downtimes very well because now you're predicting the best time to do maintenance means you don't have to keep having greater downtimes. Downtime is basically the time that you incur when a machine is not working. Basically, the time lost due to no production whatsoever. And then you've got greater remaining useful life. So think about RUI as machine life or the life, the what do you say? The period of maximum efficiency of a machine. It's basically, or in other words, is basically how long a machine can run before it completely crashes and burns, and you have to keep it aside. So predictive maintenance enables you to have greater machine lives. So those are the advantages. Now the cons are pretty straightforward. If you want to implement this algorithm, you have to pay a high initial cost because it has a lot of setups that the ordinary man cannot afford. And you need a highly skilled crew because you're talking about machine learning, and no, you can't have anyone come off from the street and implement this kind of machine and understand the various nuances involved. And I just realized I'm running out of time. So, Rohit, can I have 5 more minutes of your time if that's fine?
Sure, don't worry.
Yeah, cool. Won't take a long time. Right. So let's move on to the next one. Okay. This was right. Predictive quality and yield. Now, that name suggests quality and yield. So what do you think that means? You've got predictive, quality, and yield. 3 words, easy to understand when they stand alone. So what do you think it is? Uh, okay, I mean, I can answer it for you. So predictive quality and yield. You're predicting the quality of your goods and how much of it you're producing. And this is a process that reveals the causes of, year-long process-based production losses that affect manufacturers. What that long line basically means is you're trying to predict what are the causes behind, manufacturing losses, loss in quality or loss in yield. And you're basically using machine learning and AI models to enable you to identify those causes and predict what is the best course of action forward. Now, how does it identify these root causes or the factors behind these losses? It implements something called a continuous multivariate analysis. Now, in simple terms, a continuous multivariate analysis is, an analysis which involves uh, acquiring as many variables as possible, and then understanding how a process or an output is affected when those variables change. Because a production process involves a lot of variables, and that one human cannot, sit down and enable or understand. So AI model basically changes on each of those variables and see how the process is overall affected or how those losses are managed. Or in another way of putting it is artificial neural network, which I think Rohit had explained on a number of occasions. So this is something that I'm pretty sure most of you have basic idea about. So you basically have a number of different variables, and depending on how those variables react, your output will also react. So the predictive quality and yield analysis implements this model, which then enables people, or which enables users to modify the variables and see how it affects the quality or how it affects the yield. Now, on a side, so that was basically the two major aspects about production and how AI is impacting that. So over here, you can clearly see that there is a great scope for people who are in the computer field, in the computer science field, or in the AI field. And what this tries to tell you is we're still in the early stages, but we are making great progress in implementing highly advanced technology into decision-making processes, which can completely revolutionize the way we produce, we sell, or we make decisions about what is in our best interests. So without further ado, since we are running short of time, we'll just have one discussion about one particular kind of question. And that is, which job field do you think cannot implement AI for decision-making processes? Or one field that you think cannot be touched by AI at all because the stakes there are too high that you can't rely on a robot's judgment?
Therapy.
Anyone?
Yeah, like
And surgery.
airplanes.
Samrat?
I said airplanes.
I said therapy and like surgery. No, I didn't say airplane. I said therapy.
Well, I said airplanes.
Right.
Oh, okay. My bad.
Samrat, what do you want to tell us why you think AI or machine AI algorithms cannot, touch this field? Because, your reasons.
Which one, surgery or therapy?
Let's talk about surgery.
Surgery, yeah. So technically, yeah, the AI can, but the thing is, it won't be like it won't like become like a mainstream thing because there's just too much risk involved. Especially when you're, because the thing about healthcare in general, there's a lot of stakeholders. There's a government, there's insurance companies, there's like people themselves. There's a huge margin of risk that I don't think.
Oh man, I want to hear what you want to say.
Oh, Samrat, we lost you there.
Companies and hospitals would take in at least the near term free.
You just broke. You just kept breaking.
Hello.
Yeah, I can hear you. You just kept breaking in between. But what I can understand from whatever little you said is, surgeries involve such high risk decisions that you can't trust the judgment of a robot because there's that element of, what do you say? You're saying that a robot cannot imbibe the gut instinct that humans have which comes into play, most of the times when it comes to such important decisions. And that's why you think robots cannot or AI cannot be implemented in surgeries?
Pretty much, yeah.
I mean, it's definitely one way of thinking, because the thing about, humans being involved in a line of work or in specific lines of work is their judgment is cannot be simply classified into what the black area and the white area. There is a lot of gray area in that decision making process, a lot of things which cannot be quantified in numerical values or data points. Like what I could infer from Samrat's assessment was gut instinct, because a lot of times you'll be confronted with decisions that you can't really say is a good decision or a bad decision depending on what you choose. So you'll have to factor in a lot of other you'll have to factor in a lot of other things like emotions, like your gut instinct, like your basic instincts. And the thing about AI is you can program it and train it as much as you want, but you won't reach a point at which the robot can be like, I have this feeling that if I do this, I will get it right. Because AI, no matter however smart it becomes, does not have feelings. And if it doesn't have feelings, then it won't have instincts. If it doesn't have instincts, then you can't trust its judgment, because it looks at judgment, it looks at decision in a very binary way. And some decisions simply cannot be viewed that way. You need a gray area and you need gut instincts to enable you to make decisions that sometimes are in the best interest for the people who you're targeting. So yeah, a very interesting thought and a very interesting, case that Samrat mentioned. And I'll just talk about one other example. So Tanmay, you spoke about airplanes, right? Tanmay, mute.
Sorry. Yeah, I did.
Why would you say airplanes?
I feel like there's just a lot of things at stake when it comes to riding airplanes, because like an AI, because like we're already having kind of trouble with doing AI in like self-driving cars. So I don't know how, like, I feel like an airplane with AI wouldn't be any better, really. I feel like the casualty rate may be higher, and plus there's a lot of risk. You're carrying more people in an airplane.
Now, I would say that an argument against that is you've got a AI model or a program that assesses the situation depending on data points and other factors. So by collecting these data points, it can assess what is in its best interest and what is in its interest, what is the best possible outcome that you can have from all these, data points. But then again, you can also argue that some decisions simply are based off gut instinct, like what Samrat said. A very interesting case I want to talk to you about is, the case of Sullenberger. Have you heard about
Sagar, sorry to interrupt. I would like to comment on that airplane thing. Yeah, so what I think is like self-driving an AI-based airplane, or like, yeah, is better than or easier than a self-driving car, because like a lot of less variables are at play. Like you have a fixed path, you have no crowd, so you have less number of humans making decisions, like pedestrians. There are no pedestrians, and there are like no people running around the streets and all. It's like a fixed path, and like all the things are predictable. Like weather, you can predict, you can analyze the data from weather and all those stuff. So it's less more riskier and easier stuff than self-driving cars, I think.
now an argument
Can't always
against
predict weather.
Samrat, you said
What?
something?
You can't always predict weather, and there's other flights as well in the air. And what if there's like
Yeah, you can
communication
forecast the weather,
breakdown
though.
between all the flights? There has to be like a 24/7 communication.
Yeah, but what happens in turbulence then? What if there's like a thunderstorm? I can't really do much about that.
A lot of very well stated points here, but just coming back to Sudesh's point, he said that there are less variables at play. Now, one of the things about AI based learning is it's about implementing a model, then training the model, then modifying the model, and then again deploying it. Now, in the case of, let's say, air travel, you've coded it in the best possible way, or you've trained it in the best possible way, but then you come across a situation which is risky, which can put the entire what do you say, all the passengers' lives at risk on the plane. Let's talk about the Miracle on Hudson. By the way, have you guys heard of the Miracle on Hudson? It was how a plane was landed on the River Hudson when a bird entered the engine and completely took out its engine. Yeah. So that was a very unique case. Now, over there, Sully trusted his judgment and landed on the River Hudson, which was against advice of other pilots and professionals in the field. So he trusted his gut to take an action that was unthinkable, and it reaped benefits because they survived, all of them. Now think about it, if it were an AI model in its place. How would an AI model interpret the lives at risk, or the the feelings of the people there? One way we could think about it, it's just another training set, and if we fail, then again we'll be modified, and we will then ensure that this won't happen in the future. So for an AI model, that could possibly mean relegating the lives of those passengers on the plane to mere data points and test data that just didn't work out when it came to choosing the best possible outcome. Now, is that a risk we are willing to take? Are we willing to relegate the lives of people to mere training points, or training data?
But according to statistics, you have more number of road deaths than like airplane crashes and all.
Absolutely. Over there, you've got, statistically speaking, you've got deaths. Definitely, statistics come into play. But we're talking about an issue that was not in. We're talking about possible issues that could crop out of decisions that were not in our hand, which will then prompt us to ask us as a question: if we had something in our control, then why did we give it away? Because the thing is, we as humans, once we make mistakes, we can understand, like, our mistakes have repercussions, our mistakes hold weight. So we'll think in that way. But how can an AI model think like a human and say, okay, if I make a mistake here, I'm putting the lives of all these people at risk. I won't be able to live with myself. What kind of pressure am I feeling? Because frankly speaking, AI models don't have that human pressure because they are not humans, right? So when you don't think like a human, then you won't react like a human. And if Sully hadn't reacted like a human that time, the base of trying to survive or trying to achieve its goal of survival instinct, then who knows? They wouldn't have survived that, right? Well,
Sagar,
for
I'm so
everyone.
sorry,
Yeah.
but I would just like to request that we keep moving because
Right. I just realized it's
we're
5:30.
overshooting.
Right. So that was just a particular thought. So, or if you could just just take this back and think about this, and hopefully we'll have an even more productive session, and one with less glitches in the future. So thank you all for this discussion. Hope you all enjoyed it, and back to you, Rohit.